Today we're going to be taking a look at heatsink number 11, and this is courtesy of Pablo, and that heatsink is the Digifast M.2 2280 SSD Premium Heatsink. So we're going to do the four things we always do. We'll do an unboxing, we'll do an inspection, we're going to do an installation, and then we'll do the test. Now Pablo has asked us to take a look at two heat sinks, and this being number 11, and then we'll be followed by number 12. And number 12 we may do a little bit more than just the heat sink, which I'll get into when we get to that. So we've got two in here, and I'm going to show you the Digifast. Fantastic. I expected the box to be a whole lot bigger. And the next one we'll be looking at will be that one, but not yet. And then one other item in here we'll look at later. Now the three places we're always looking at for a heatsink. Number one, a dual M.2 NVMe adapter. We'll go over the specs of the machine in a few minutes when we get to that. Number two, a quad adapter that should have a cooler that does not. And then number three, the motherboard. This one should work in all three places. Feels lightweight. The question, of course, is going to be how effective is it? Looks like we have a factory seal. Good to know. I like the layout of this. I was a little concerned about the height. I thought this might be appropriate in another location like a PS5, but I don't think that's going to work. Too tall. So if you're on a motherboard and you're concerned about height because you got I/O cards that are going to be above it, this is not the heatsink you're going to be looking for. But however, if you're not concerned about anything above the heatsink, this is one to look at. It's all aluminum. We have our standard three components. We have the carriage on the bottom, we have a heatsink on top, and we have thermal pads. Now in the description it talks about one thermal pad, but I've looked in the documentation where the people are asking, there's two thermal pads here. Those look thin, but I'm hoping they're 1 millimeter. This also says it will work with single-sided and dual-sided. I don't know about that. We'll see. I like the way the lip is on one edge, so that memory, when we slide it in and set it, you'll notice the notch. And there's a lip with that groove. When we set that in there, it'll stay put. So now I need to see if I can pry this up. Yeah, I had to put a screwdriver underneath there to pry it up because it fits kind of tight. It's been wedged down into the base. The manufacturing kind of reminds me of what we had on the Gigabyte copper. Now the screw holes are not elongated, and this red anodized aluminum and then this base that's black, the way the holes are punched and recessed so the screws will be flush, makes the spacing between here tight so it fits right into these grooves. And as far as the heatsink goes, in terms of length, the only length we have to concern ourselves with is this length and this lip we have right here, which I like. So the memory will slide right down to that. So this should go pretty quick. And for the other parts we have our screws, we have a screwdriver, and again, of course, our two thermal pads. And our testing, of course, will be with the drive we've been doing all the testing with, which means I need to bring up the chart and show you guys for some reference. Let's take a look at that chart. The WD Black SN850 that comes in at 92 degrees, and our goal with this cooler is to stay below 80 degrees. How well will it do that? I have no idea. We're going to find out. And our best has been with the heat pipes, to reiterate that. Number 5, the Sabrent Rocket 3 heat pipe. Number 9, the Acidity 4 heat pipe. Now, on this list we have numbered from 1 to 16. Other total heat sinks we have tested, there have been 10. But there's been more than just those 10 heat sinks. In other words, we have the drive numbered, the number 2, the TRX40 Designare second heat sink on the motherboard, 65 degrees and so forth. Anyway, the point, once we connect with these this one and the next one, these other two heat sinks, then that list will go from 16 to 17 and 18. And quite possibly because of what we may do to test not just this heat sink, but the next one. The next one we may be testing two ways, but I don't want to get into that. We'll save it for that video. But I'm just saying the number list is going to grow. So I want to orient you to understand how that number is. And so when I'm talking two sets of numbers, the numbers you see and the numbers that are in my head, this is number 11. But on the list, it'll be number 17. So we're good to go for that. I really like the Gigabyte Aorus copper. We tested it two ways. One on the dual M.2 NVMe adapter and number 2 on the motherboard. So that's why we have two different temps. So we're going to need to get the stuff out. And since I've got to handle memory, that means I need to suit up. For those that choose not to, that's your choice. We choose to do that because that is recommended procedure. I'm not going to go into that. We have in other videos. And also, as a reminder, we keep the labels on the drives. If you want to take those off, again, that's your choice. We do that, otherwise we wouldn't know who's on first. We now have our dual M.2 NVMe adapter, and this is the Supermicro dual M.2 NVMe adapter. We have a Samsung 980 Pro, and we have the WD Black SN850. And because of the last test we did, we're going to reverse these, put this one back on top, and test in the top position. I like the weight of this, and just based on the weight of this, I hope this is a good cooler because, like I said, to reiterate, I think this will work in all three places. Depends on the temps. That's what it's all about. And since we have two thermal pads, we will use both. So I'm going to go ahead and get my memory swapped around so they're good to go when I'm ready. I hope you guys, while I'm at it, had a chance to watch the video that I had a link up about AMD with Phison and the I/O optimization. That was pretty wild. I think we're going to be getting some more into that. That was a whole lot more fascinating, and I've got some more information I'll share in a little bit later on as we get through this test. Because going forward, based on the Phison E18 controller, there's going to be 3 drives that we're going to want to focus on. And one of them is not the WD Black SN850. I'll leave it at that. Okay, yes, 2 thermal pads, and these are kind of thin. These do not look like 1mm pads. These look like 0.5 millimeter pads. Curious. And then, of course, our set of screws. So the only thing I need to do is double check and dry fit. Kind of see where that sits. That looks good. Now I'm going to keep this zoomed in as tight as I can so y'all can see specifically what I'm doing. And based on the way the memory is going to sit, let's look at the notch. Okay, I'm going to hold that right in the center so that it doesn't tip over. And lengthwise, I like the end on the left with the notch, and I like the end on the right where the notch for the M.2 connector sticks out. That's a pretty good bit, the most of any of them. So let's get this bottom pad on and see how well this thing works. I'm also curious if this screwdriver is magnetic. I hope it is. We're going to find out. Because those are teeny tiny screws. Nope. But I have one that is. Okay. Oh, yeah, it is. It's just not as strong. The one that comes with it is magnetic. It's just not as strong. Okay, I'll set that aside. Because I'm going to have to use a flat, straight blade micro screwdriver so that I can get a corner of this and peel the pad off a little more efficiently. Pull one side off. I like to save these. And if these are the default pads like most everybody uses, these are probably 4 W over MK. You would think they would go ahead and supply some thicker pads. Bottom pad is down. Grab a corner. Grab a corner and peel that straight back as it rolls just a little bit and stretches. Not bad. I can live with that. And again, save the covers. And the memory, we're going to have the same issue sliding this in because of the way the screw holes are indented. So I've got to slide that in underneath, but still keep that supported up above and just let that drop. And it hits up against that notch and we're set. Something else I got to point out that I didn't realize till just now. There are ridges here on the side that change this width. Let's see if I can zoom in a little bit more on that. When I slide that memory in there, you can see it easier from the outside. Those indentations are an indentation just like the screw holes. There's 1, 2, 3. Now I don't know if that means that the memory is supposed to ride above that or if the memory is supposed to be squeezed by that. But I can tell you when I put the memory in there, I am not touching the thermal pad. And how I noticed was looking down through here and I see daylight through there. See that? I can see daylight through there. Having that bottom thermal pad is absolutely useless because I'm not even resting on the bottom. Now that may be to accommodate the double-sided memory, and in which case I can understand. However, if we're going to put a thermal pad on the bottom, there should have been another thermal pad included. In other words, 3. And one of them should have been, both of the ones on the bottom should have been 1 millimeter to accommodate that cavity, that gap. That's most Most unusual, but it is what it is. And no, I'm not going to try to press it down in there, but I can tell if the memory were flipped over, as I see the size of the PCB, which is 22 millimeters wide, 80 millimeters long. The width of the memory is not 22 millimeters, so if this were flipped, that would sit down on that. So that helps me to understand and see where they talked about in the description. Somebody asked a question about single-sided or double-sided. That's how they, I guess, accommodate double-sided memory, which is, how about using elongated holes instead? That makes a whole lot more sense, so we can get some compression. Because now we're just sitting up above a thermal pad that's not doing any good. Anyway, I digress. But I think details matter. Let me come out on that just a tad. Okay, so we are set as far as this way, and we're up against this bracket on the left end. So I'm good to go with that right there. And you can see the clearance we've got here on the right side. That's the most clearance we've had on any of them. That's almost 1/8 of an inch. Amazing. So the next step is to get the next thermal pad on there. These thermal pads are not as fragile as some we have worked with, which I find kind of interesting. And I will roll that and go from this end because I don't want any past that controller. Roll it a little bit and set it. Okay. And I will peel from this end. But that thermal pad on the bottom does absolutely no good with single-sided memory. I've never seen one designed quite like this. Peel. A little bit of a stretch. Good to go. Again, save my covers. We've been asked about 2 other heat sinks that are not available right now and will not be until probably next month. Next month being right now, this is, I believe, sort of middle of the month. Now looking at the heat sink, there's no left or right to it. It's just it's the same on both sides, both ends. So whichever way we want to turn it, depending on how we want to see the design. So if we put it on this way, when we turn it up, we won't see it. If we want to see it, we'll turn it this way. So when we turn it up, it'll look like that. So I'll drop it in, and it fits right into those holes because the indentation is designed for it. But the memory is just sitting there. There is no compression. And the brackets where these indentations are, if I can turn that a little bit, you can kind of see. Let me see if I can zoom in on that some more. That's as close as I can get. You can kind of see with these metal indentations, that little bit of a green yellow edge there is the PCB right in there. So it's up supported. So this is single-sided, to reiterate, to accommodate double-sided memory. And I can tell the drive is sitting, but it's not tight. It's loose. So all I can do is put the screws to it. Assembly was pretty simple and straightforward. Well, their screwdriver I thought was magnetic, but it's not magnetic enough. So I am, again, to reiterate, going to use a different screwdriver that's a little more magnetic so that I can hold on to those screws. That definitely should be magnetic. That's just my opinion. We started this with 6 heat sinks. We went to 8. We went to 10. We did another one, which I want to thank Joey for, which was the Gigabyte. But I don't count it as 11. This I count as 11. Okay, I'm just getting those screws started, and we'll see what we've got. Well, to reiterate, this will not be working in a PS5, which means it's not going to be any good in a laptop. But on a motherboard where you don't have to worry about your I/O cards over it, or for a dual M.2 NVMe adapter or a quad, this should be ideal. Question is, how good are the temps? And for those of you that I have to mention again that saw that I/O optimization from AMD and Phison, you might want to watch that 2 or 3 times and download the extra material. And I would suggest if you have not watched it, or excuse me, if you did not watch it live, go watch it and download those resource materials. Because I have a PDF file from that, and I'm going to show you some information on 3 drives that we need to be focused on in the future. Okay, screws are all set, so now I'll go ahead and drive them all the way in. Now there's 3 screws on each side. That's 6 screws, so we have 2 spares, which was nice. I don't remember anybody else providing spares, but the screwdriver was not not magnetic enough. How's that? And we'll take the 2 extra screws, get them back in the bag, because you never know. Let's get our adapter up here. Supermicro dual M.2 NVMe adapter. And the Digifast. Interesting. Let's get that on the card. And we've mounted that to the WD Black SN850. On the connector, apply the escutcheon pin, and we are set. Now we'll roll it over. Let's double check our components. One component I'm always concerned about. And we have clearance. Excellent. And I've turned it so the label is facing up for what it's worth. And the way that's designed for heat, they probably mean that to be turned the other direction since those aren't straight, they're at an angle. However, that's the way I did it so I could read the label. So we're going to see how this works. So unboxing, inspection, installation, and of course the test system. This is the Gigabyte TRX40 Designare, where we have 2 16-lane slots and 2 8-lane slots. And we're going to install the Supermicro dual M.2 NVMe adapter in that first 8-lane slot that's set up for 2 drives because it's bifurcated in the motherboard. So we have 4 lanes for each one of these 2 drives. And clearance looks pretty good. However, there is, and it's hard to tell, but there's a single lane slot right at the end of this red nose on that screwdriver, which is about in line with the Digifast heatsink. Using the Digifast heatsink, I cannot use that single lane slot. Now, what would I want to use that single lane slot for? Well, glad you asked. Say if I wanted to use a capture card that did 1080, I can't. I always say change one thing, changes everything. But let's see how this does its job. And set. So now what we need to do is video is plugged in. We need to plug in power, turn it on, energize. Once the computer is booted and up, we don't have to go to the BIOS. Like I said, to reiterate, bifurcation's already been set. We'll go to Windows, we'll double check, make sure our drives, because there's labels on the drives. Then we'll go up and do our test, and we'll bring up hardware info on one side, do our speed test on the other. I'm curious to see what kind of results we're going to get. And while we're waiting for the computer to boot, after watching the video that AMD and Phison did about I/O optimization, I got a sneaking suspicion we're going to be doing some stuff about that with these drives. We'll see how that plays out. To Windows. All right, first things first, Windows flag E. We'll double check this PC. The WD Black SN850 is drive letter D. Hardware info, sensors only, and we're looking for drive telemetry on that drive. The WD Black SN850. We start out at 34 degrees, we're on a cold boot. And the drive below it, the Samsung 980 Pro that has 2 thermistors, starts out at 37, and then the second thermistor starts out at 45. Okay, we're going to be watching this one, the WD Black SN850. So we will bring up Crystal Disk Mark, and we're looking at drive D, 1 terabyte drive, 1 gigabyte test file, all. And I hope for those of you that have had a chance to look at the other results from the other tests, some of the stuff that I have repeated before, I won't in this one, such as we're at 7,000 megabytes. Can you imagine a drive that gets not only over 7,000 megabytes on the read, but also can get 7,000 megabytes on the write? I got to tell you, you got to watch that video. Look at the link that we put up. The time we spent doing that video, it's going to be well worth it. And I'm going to show you 3 drives we need to start looking at and talking about. One of them we've already talked about, but I didn't realize it could get 7,000 megabytes on the write. That kind of blew me away. But it's not just the E18 controller, it's the Micron memory they're using as well. Details matter. So as good as the numbers are on the WD Black SN850, there are 3 other drives that have the potential to do better. A highlight, our minimum, maximum, and average. And when we get through, we'll go back and look at the chart, check our numbers, see how well this scales out. And remember, we get the hottest temperature when we get to the second number of the megabytes on the right. And this is a burst mode test. This is not a throughput test. 2 ways we could demonstrate that. One, with this test running it 3 times consecutively. Number 2, and some of you have asked, which we will probably do later, would be to take a file of a specified size to run for a specified amount of time. Copy it from drive A to drive B. Then with another file with those same specs, copy it from drive B to drive A. That way the 2 files are not in the cache. Now I think the first improvement that could be made, whatever the numbers are we get, will be with the thermal pads. Again, to reiterate, I do not care for the thermal pads that came with this. They don't look like 1 millimeter, they look like a 0.5 millimeter. And of course, the thermal pads to use would be the Thermal Grizzly minus pad 8. And I want to thank Pablo for making this test possible. Just like the test that Joey made possible where we got to test the Gigabyte copper. That was fascinating. I really like that Gigabyte copper. Well, I'm impressed. Wow. 56 degrees. I'll hold off till this is finished. Once it's stopped, then we'll go over the numbers. Wow. I'm kind of blown away by that. Well, we always say change one thing changes everything, and one thing we've learned about these heat sinks, all assumptions out the door. No matter what you think you know, you don't know until you try it and test it. That's a good example. Okay, test is complete. We now have at 56 degrees. Wow. Okay. So our WD Black SN850, PCI Express 4.0, second generation, a little over 7,000 megabytes. We're on position 1, the top position on the Supermicro dual M.2 NVMe adapter. And those numbers, as we look at the chart, the WD Black SN850 at 92 degrees, and the TRX40 Designare, the second heatsink, which would be, you can't see it, but the heatsink on the motherboard, because remember we have 2 M.2 NVMe connectors to the CPU. We have 2 more underneath the video card under one heatsink, and those 2 are through the chipset. Those are the slowest. So this second position that's right below that red Digifast, that's where that second number comes from. And that's on the motherboard with one thermal pad at 65 degrees. And we've just tested out at 56 degrees. As always, the more I learn, the more I realize how little I know, and the more I realize I need to know more. Wow. Pablo said he thought we might be impressed. I'm like, well, if you want us to test it, okay. He made the donation to cover the cost, so that's the numbers, and I'm impressed. Now, our best, number 5, the Sabrent Rocket 3 heat pipe at 54 degrees. Number 9, the Acidity 4 pipe at 48 degrees. However, when we look at the numbers on this drive, and we came in at 56 degrees, and that's just aluminum. There's no copper in there, just aluminum. I have to look 3 times at that. 56 degrees versus all these. So, you know, when you think about number 5, the Sabrent Rocket 3 heat pipe, that thing's huge at 54 degrees. And this came in at 56 degrees. Oh, wow. Yeah. Wrap your mind around that. So, is that a top performer? In my book, it is. Can the numbers on that be improved? I would think so with different thermal pads. Does that mean that's going to be one we're going to test? More than likely. We still got one more to do. Now, I expect this other one's going to have some great numbers, but it won't work on a dual M.2 NVMe adapter. It will only work on the motherboard. Now, do I need to test this on the motherboard? Stand by. Okay, first thing we got to do, shut the machine down, get that on the motherboard. Now, to get this in here, because the close proximity to the video card, even though the video card, which is an RTX EVGA 2080 Ti, I can't get my fingers in there. So I have to pull the video card to get this on the motherboard. But we have to test and verify. I'm glad I have not reinstalled the motherboard heatsink yet so that I can do this. Otherwise, PITA. And because of the way that sits on there, the double screw I assemble so that goes on as one piece. And that uses the number 1 Phillips to drive those both down. Okay. On the motherboard, we'll reinstall the video card. Video card is good. Reattach video output, reattach power, turn it on, energize. Fantastic. And the 3 things I like to see: number 1, I know I've got power to the video. Number 2, I can see the post codes up here in the top left. Number 3, I can hear post because I have a PC speaker where my finger is pointing that you can hardly see. I like to hear that power on self-test. We'll go back into Windows because we don't have to do anything in the BIOS. Windows, because the drive letter assignment will see the drive, but I'll double check it just to be safe, just to be certain. And then we'll run the test again. 56 degrees. Wow. Trying to wrap my mind around that. I did not expect that. What did I expect? Oh, you know, based on the stats, somewhere around, 65. I got to stare at that a minute. Pablo, thanks for making this possible. And by the way, welcome to Build or Buy. My name's Gil Boyd. I want to thank you for joining us. To Windows. Windows Flag E, this PC. And remember, the dual M.2 NVMe adapter is removed, so we're only seeing the one drive, the WD Black SN850, which is drive D. Now we will bring up hardware info, and again run sensors only. And we are looking for drive telemetry, and this is smart telemetry. for the WD Black SN850. Minimum, maximum, average, we're starting out at 43 degrees. Cold boot, but not a 24-hour old cold boot. Just long enough for me to monkey with it. Okay, crystal disk mark, drive letter D, 1 terabyte, 1 gigabyte test file, all. We'll highlight, see where the temperature goes. Only way to know is to test and verify, as the man said. Test is complete. We topped out at 62 degrees. That's on the motherboard. That's curious. So the difference being from the dual M.2 NVMe adapter to the motherboard. And we went from 56 degrees on here to 62 degrees on the motherboard in the second position to the CPU. Fascinating? I think so. Wow. Pablo, I'm glad you want us to test. Let's look at the chart. So the WD Black SN850 at 92 degrees bare drive. On the motherboard in that second position with that heatsink that comes with the motherboard, which means 1 thermal pad, 65 degrees. And we came in at 56 degrees on the dual M.2 NVMe adapter by Supermicro, and on the motherboard we came in at 62 degrees. So that tells me we finally found a replacement heatsink on a motherboard, as long as you don't have to worry about I/O cards above it. If you do, then that's a problem. But if you don't, you got it solved. Now I want to throw this up. This was from the AMD Phison I/O optimization. The Phison controller, the Micron memory, and they used 2 Asus Hyper M.2 quad cards by 16. And they did it on a Asus TRX 40 motherboard. Okay, the important thing here, 3 different drives we need to be looking at. One, the Seagate FireCuda 530, which we've talked about, the Corsair MP600 Pro XT, and the Teamgroup CARDEA A440. I'll have links up on those so you can find them. They were not as concerned about heat, although they mentioned it, as much as I think we are. But with what they did, they had the results. And with the 6 tweaks they did, they were able to increase the performance. And my takeaway from that video, based on using 2 of those quad adapters, you're better off with 2 quad adapters than having 1 adapter that's got 8 drives on it. That was my take. So I still would like to look at the Gigabyte RS Extreme card that's going to have 8 drives, but it's got a PLX chip to do that. But what they didn't tell was how they did the video on that motherboard, which means the video was on an 8-lane slot. There's a lot they left out. What they shared was great. What they didn't show was not so great. But I got enough from it that I can see we're going to be doing some stuff and talking about it. But these other 3 drives you got to be thinking about. So we got one more heatsink to do. I want to thank you guys for watching. This is Builder By. My name is Gil Boyd. Thanks for joining us. We're on to the next video. We're out.